Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies, protecting over 7,500 applications and 150 billion production requests per week. Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences' patented technology protects any application against any attack, with integrations into any DevOps toolchain. Signal Sciences. Demand more from your WAF. Learn more at signalsciences.com/PSW. Introducing the new DigiCert. As the leading provider of high-assurance SSL, TLS, and PKI certificates, DigiCert is all about improving security across the web and IoT. DigiCert is committed to helping customers and partners successfully deploy identity, authentication, and encryption solutions. They'll even help you figure out which certificate you need to secure your web domains, apps, devices, and more. Check out the Cert Wizard tool under the SSL tab on digicert.com. Welcome back, everyone, to Paul's Security Weekly, because that's the name of the show, because I dropped my keyboard. I didn't drop it, I put it on the ground. Anyway, make sure that you check out some of our on-demand material. Basically, we've been recording webcasts secretly here in the studio all year long. And we put them up on a website, securityweekly.com/on-demand. They're on really cool topics, and they're a secret other than we've been announcing it on the show. So you can go to the on-demand page and you can register and attend those webcasts.
And how much do you charge for those?
It's $0, just your registration.
Absolutely
fee.
Free.
Yes.
Can't beat that.
Absolutely free. You're just going to register, and you can consume that content. And again, I mean, we choose sponsors here because they're awesome, basically, is what it boils down to.
Yeah.
So, and Sven works for one of those awesome sponsors, which is Netsparker. Netsparker has been with us for some time. I caught up with Pharaoh at Black Hat. Always smiling and having a good time, that Pharaoh. It must be awesome to work for him. Sven Morgenroth is here from Netsparker. Sven, welcome back to the show.
Thank you very much. Thanks for having me.
Yes, nice to have you here this evening. And Sven, you're going to talk about some PHP type vulnerabilities. Is that correct?
Yeah, type juggling vulnerabilities. If you want, I can show you what I mean with that.
Sure.
So I'll share my screen with you now.
PHP is, of course, one of the more secure programming language web frameworks.
Of course.
No, of course.
Secure
can
out
you
of
see
the
it?
box.
I can, yeah, if you want to dump into presenter mode.
All right.
So
I called my talk PHP Type Juggling Vulnerabilities, or why weak typing equals trouble. And let's first start with a few data types in PHP and why we need different ones. So, for example, we have integers like those, or we have float, aka double or real numbers. They look like these. And we have strings, like PHP is flawless. Of course, we also have data structures like arrays. They look like this, and you see you can have different data types in arrays, integers or strings, or yeah. And we have objects in PHP. Now, of course, if you have different data, you want to compare it at some point. And that's relatively easy, right? So you have, for example, integer and integer. 1 equals 1 is true. 1 does not equal 1 is false. We also have strings and strings, so it has to be the same string, and it is true. For example, oh, what a great language this is. And PHP is not the same as complicated is true as well. We can also compare arrays like this. 1 to 3 equals 1 to 3. And 1 to 3 does not equal 4, 5, 6. See, it's relatively easy.
Yeah, I'm with you so far.
So
no, you're not.
Yes, I am. I am. For once, I'm usually Sven has lost me by this point, but I'm right there with you. Now he's probably going to lose me, but anyway, go ahead.
No, it stays relatively easy, right?
Okay,
we have different values, and PHP is very like forgiving if you have different data types you want to compare. For example, integer and array, there's no comparison possible for those. And we have integer and float. It will be converted to float, I guess, because 1 does not equal 1.5, but 1 equals 1.0. And we have integer and strings. They are converted to integers. Like 10 equals string 10, but 2 does not equal the string 2 when you see it. However, 0 equals the day since PHP last confused me is true as well. That's relatively weird, right? That doesn't make much sense. So 0 equals some string. Well, okay. Why is that? And it makes sense. I promise you it makes sense. At least the PHP kind of sense. That is a thing. So this is what PHP allows you to do. 2 equals, for example, 2 cans of lemonade, which makes programming obviously a lot better and easier. And I don't know, like you wouldn't do that with a function otherwise.
It takes the first character of the string and interprets it as an integer and then compares it to the integer?
Yeah, kind of. But don't worry, it gets more complicated as we progress.
Oh, okay, great.
So when comparing strings and integers, PHP converts the string to an integer by extracting the number at the beginning of the string. That's exactly right.
Yep.
There are edge cases, though, because of course there are. But still, why does 0 equal some string? That's the question here. And
the integer has to be in the first position, or does it look for the integer anywhere in the string?
It has to be on the first position.
Okay.
You will see a table later that explains a few of these comparisons.
Okay.
So we have the number 2 at the beginning of the strings 2 cans. And PHP always converts the string to an integer when comparing these types. So it's 2. The resulting comparison is therefore 2 equals 2. So 0 equals cans would be no number at the beginning of the string. PHP still wants to convert to the string to an integer. So if there's no number at the beginning of the string, it must be 0 cans, right? And the resulting comparison 0 equals 0. Easy, told you so.
I'm with you. I'm still with you.
So that kind of makes sense, I guess. That's the only weird comparison, though, isn't it? Well, of course it is. Not because it's PHP. And if Paul was following along until now, I think that's over now.
It's time to drop him.
That was awesome.
Yeah. I mean, that's PHP for you, a table of comparison. Now that's interesting, isn't it? So the correct question now is, what is going on here? So we have a few highlights. For example, an empty array equals false. However, of course, an empty object equals true. We have 0 ABC with a 0 at the beginning.
Is empty the equivalent of null? Because I'm a C guy.
Can you repeat that? I didn't get that.
Is empty the equivalent of null?
Yes, we get to that in a minute. So
Okay,
0 ABC equals 0 because there's a 0 at the beginning of the string. However, 0x2 equals 2 because why not? And false equals null.
Because what?
And the string 0 equals false, but of course the string 0 does not equal null for whatever reason. And that one is also interesting. We have 2 strings that are different, obviously, but they compare to that they will result in a true comparison. Like that is true. And we'll get to that soon because that's actually quite serious. Okay, we get it. PHP is strange, but is it insecure? I would say if you can memorize dozens of edge cases for a simple operation, you're probably fine. For us mere humans, that's not really that easy. It's very problematic, actually. And programming languages should be predictable if you especially for security critical stuff. And comparisons occur everywhere. Like I don't know if you can read 10 lines of actual code without seeing a comparison. And this is not PHP's only problem, of course. So are there any vulnerabilities arising from type juggling? There are quite a few, actually, such as authentication bypasses, crypto-related flaws, hashing algorithm disclosures, and a lot more. But we will focus on these first three here. So authentication bypass. We actually have an example here that's also on the Netsparker blog. It was CMS made simple. And they checked whether the user was authenticated by comparing a value in a cookie with a password hash from the database, similar to this code. So if the hash was in the cookie and it was equal to the hash in the database, they would authenticate you. Some kind of remember me function when you're logged in. And actually, that's not quite as exploitable as you would hope, because you can get only two useful types of data from a cookie. In PHP, those are strings and arrays. And actually also null, if the value doesn't exist. And if you paid attention, we usually need two different types in order to abuse type juggling, like an integer and a string, or something like that. Okay, so string equals string won't trigger type juggling, at least not always. We'll get to that too. And so in order to return true, if we compare this hash to something, we would need the actual hash if we would compare it with a string. We could compare it with the integer 0. That's not possible though, because we can get only strings and arrays from PHP cookies. From cookies with PHP. And of course, true would also work, but same as above, we can't do that. Luckily, CMSMS stored the cookie content as serialized string and deserialized it with the unserialized function, which is like, I don't know, completely insane. If you know what unserialized does in PHP and in many other languages. Why they did that, I have no idea.
Yeah, I was going to say, why would you serialize the password hash or the hash string in a cookie?
I have no idea. I think the complete cookie was serialized. And,
okay, gotcha.
It was encrypted with a function called encryption or encrypt that was rotate 13 and base 64, I think.
That's wicked secure.
Yeah. So yeah. So something like this in a cookie would lead to an authentication bypass. That is a serialized PHP array, like this with one. I think it was like that with one element of the key hash and the value true. And the explanation was a bit simplified, but this is actually how it worked. There was more to it than just the loose comparison, though. Like the correct cookie name had to be created in order to abuse the vulnerability. That was a hash from different constants, like the path to the PHP files and stuff. But it was brute forceable though, so that was not a big deal. Some of it was also static. Now you can read more about it on the Netsparker blog if you're interested. There's a link. It's a bit long, so you can just type juggling CMS made simple in Google and search it like that if you don't want to type the link into your browser bar. Then we have some cryptography related flaws. I say cryptography related because it doesn't actually break the cryptography, except if you would use it in an actual implementation of cryptography. I don't know, but I'm talking about.
It's okay. Most cryptography doesn't break the cryptography.
It's true.
Go ahead.
Okay.
Yeah, most attacks don't break the cryptography. They break the implementation. So yeah.
Yeah. Okay. So have you ever heard of HMAX? Probably you did.
Yeah. Oh God. Setting up IPsec VPNs back in the day, nightmare.
So it's short for hash-based message authentication code. And web applications, you often use it if you want to send data and you don't want the data to be tampered with during transport. For example, if you use serialized strings and form fields or something like that. And you send this data together with the HMAC code, and then you compare, you create the same code on the server side and compare if it matches. And yeah, so you need 3 components in order to generate one, and the message, for example, a serialized string, then a secret key, and a hash function. You generate it similar to this, like first you append the message to the key, and you hash that, and then you append this hash to the key and hash that again. So you just don't use the message and append it to the key and hash that simply because it would enable length extension attacks that would allow you to create a valid key by abusing the way hash functions work. But that's not important. Important is, in order to check whether an HMAC is correct, the same algorithm has to be applied to the message we send on the server side in order to compare the hash of the message with the hash that was applied. And how can we abuse type juggling here? With scientific e-notation. Now remember the weird thing we had before, the 0e1 equals 0e99 comparison? And PHP converts these 2 strings to the integer 0 for some reason. And they are 2 strings, so why would PHP convert them? In scientific e-notation, I think that's how it's called. I think 0e1 means 0 times 10 to the raised to the power of 1. And 0e99 means 0 times 10 raised to the power of 99. And so as long as the 2 strings consist of 0e, followed by numbers and not any characters, PHP will convert both of them to the integer 0 and compare them later. Now, how do we exploit this? We exploit this with brute force. So let's assume we have the message, like a message like this, and this is the HMAC, the code that was appended to it. And if we send it back to the application, it will use the message, generate the HMAC, and compare it with the one we supplied. However, now we send the message like this, with a 1 here at the end, and something like this. So anything beginning with 0e and 99999, etc. And then the message will look like this. If we do it a second time, so we just increment the number. So eventually, after a lot of tries, we will have a payload that will produce an HMAC starting with 0e and ending with numbers on the server side. And now PHP has 2 HMACs to compare, like the one we supplied, 0e9999, and the one that was actually generated on the server side by a modified payload, something like that. And PHP will convert both these strings to integer 0 and compare them afterwards. And since both match, our modified payload is executed. If that was confusing for you, on foxglovesecurity.com, there's an actually real-world example where this was exploited. It's a pretty good explanation, and like I said, it's a real-life example. Okay, we also have information leaks, like hashing algorithm disclosures. Loose comparisons allow you to detect weak hash algorithms on the server side. They also tell you whether the hashes are sorted, and it's an easy check. So usually you wouldn't find out about this. If you would log into a service, you wouldn't know how it hashes your password. There are probably some ways to find out if it's in clear text, if they send it back to you. But generally, you can find out if it's MD5 or SHA-1 or anything like that. So hashing algorithm disclosure with type juggling works like this. From the previous example, you know that 0e123 equals 0e234. we create an account and use a password that will produce a hash beginning with 0e and ending with numbers, like this one. This this number here will result in this MD5 hash. Then we will try to log into the account. We won't use the password we've registered with, like this one. However, we use another string that produces a hash in the same format, like these characters and numbers. And this will produce a hash like this.
That's where you're brute forcing. Like, you know that when you MD5 that particular string, that it's going to start with 0e something.
Yeah, and that's to find out what hashing algorithm was used on a service, how they hashed your password.
And in the previous example too, that's what you're brute forcing is to get the string you want to be in that to have the same hash value or a hash value that will be compared and equal true.
Exactly.
Gotcha.
So what does this tell us? If the application logs us in with these two different passwords, the application uses weak comparison for password hashes. It uses MD5 for hashing. The hashes aren't sorted. Otherwise, the two hashes wouldn't be equal.
Right.
Some string would be appended. Now, if we're not logged in, either the application doesn't use weak in comparison, another algorithm was used than MD5, and the hashes are sorted. Now, that works with any other hashing algorithm with two strings that produce a hash in this format as well. So PHP is completely insecure. Completely, no. You can enforce strict comparison in PHP with 3 equal signs. Is that confusing? You have to decide if it is. There are other languages as well, like JavaScript, that do something like this. But their comparisons are not that confusing as far as I'm aware.
I gotcha.
And you can read more about type juggling on the Netsparker blog, like on this link. And finally, you can look at the comparison table for strict comparisons, with which I think is a lot better than the other one. So, okay,
yeah, that was a global variable in PHP. Was that an ini file setting? Use strict, or can you set use strict to the top of your code in PHP?
No. You have to actually use this these 3 equal signs instead of 2.
Okay, so for comparisons, it doesn't matter what your configuration is. It doesn't matter what global variables. To use strict comparisons in PHP, you have to put those triple equal signs.
I think so, yes.
Okay.
I might be wrong though, but
because I remember seeing some setting like use strict
it.
in PHP, but I don't know globally what it applied to.
I'll see if I can find that for you.
Thank you. I have vague memories. I try and stay away from PHP nowadays.
Why?
Right? For writing vulnerable applications, it's awesome.
It's a beautiful language.
Yes. Says the vulnerability researcher, right?
Exactly. So it's a fun one, at least.
That's really awesome.
Where did you get that type chart there, Sven?
There's actually, I don't know if it was on the PHP website, actually, where I've seen one like this, where I got the idea. But it was not very verbose. So this one I made myself.
Okay.
With PHP code, actually. I made a table and HTML and printed it like that.
Awesome.
I didn't, I don't know. I didn't have some ransomware pop up on my computer, so I think I got lucky.
And you use triple equals to do your comparisons.
Yeah, on that one. Felt a lot
Awesome.
better than the other one.
Awesome. I hate the double equal versus triple equal because it's when it's like 2 a.m. and you're writing code, you're like, why isn't it working? And it's because you like missed an equal sign somewhere.
Yeah, I mean, it should be the other way around, right? So the 2 equal signs for strict, and the 3 if you want to have the benefits of weak comparisons.
Yeah, if you want to write insecure code.
Exactly.
Yeah, well, that's a great example of how
character mod. You have to like work for it.
It's a great example of how PHP is just very insecure right out of the box.
Yeah, true. That is true.
Awesome.
I mean, it was also. I don't think that a lot of these vulnerable application the developers probably know about that it's weird and that you shouldn't use the double equal signs and those critical security related stuff. But as you said, sometimes you just write 2 instead of 3 because you forget it, or you just hit it twice.
Well, they're trying to make it
it's-
easy, Sven. By having the default be not use strict, they're trying to make it easy so that your code works better. Make it easier.
That's probably also a reason.
Now, Sven, have you looked
So
at
it works better, it's just not accurate.
Right. Or secure.
Sven, have you looked at other weakly typed languages and seen if they're similar like this in any way?
Not yet. I know that JavaScript also have some weird comparisons.
Okay, yeah, that's one I was thinking of.
that. I didn't look at it extensively though, but maybe in the future I will.
Yeah, I got to think it's going to be similar when there's no...
Other languages probably have similar
Yeah.
issues, whether or not they're easily exploitable like PHP.
Right, with this non-strict typing.
Exactly, but I don't think anything compares to PHP in that regard. Like I don't think if you would compare to the string 2 cans in JavaScript that it would return anything than false, other than false. And I don't think that it's that weird, but it's probably also the more subtle, but
Right.
but also dangerous.
Well, Sven, thank you very much to our listeners. If you want to follow along with that technical segment and watch the video, make sure you visit our YouTube channel, go to our technical segments playlist. This will be in there. I know on audio that might be difficult to follow without the visual aids. So, in seeing Sven had slides up for that. So I probably should have mentioned that in the beginning, because if you're listening, you probably fast forwarded by now.
I think our listeners are smart enough to say, hey, we should probably watch this.
Yes, we're working on that. We're working on making that easier for our listeners and viewers. So, Sven, thank you so much for appearing on Pulse Security Weekly.
Thanks for having me.
With that, we'll take a short break, come back with the security news for this week. Stay tuned.